As a principal part of our project, we have the Lenz's law. So first we have to know that magnetism is a phenomenon associated with magnetic fields, which arise from the motion of electric charge. This motion can take many forms. It can be an electric current in a conductor or charged particles moving through space, or it can be the motion of an electron in an atomic orbital. Magnetism is also associated with elementary particles, such as the electron, that have a property called spin. The basic elements of magnetism are magnetic fields and their effects on matter. The evidence for the presence of a magnetic field is the magnetic force on the charge moving in that field. For a practical demonstration of Lenz's law, cylindrical magnets are used that drop vertically in a copper or aluminum tube. It can be verified experimentally that the force opposing the weight is proportional to the speed of the magnet. Magnetism is capable of slowing down the movement of magnets through a copper cylinder, something that Lenz already thought. He enunciated that would later become known as Lenz's law. So, Lenz's law states that the current induced in a circuit to a charge in magnetic field is directly opposed to the charge in flux and exerts a mechanical force that opposes the motion, and with this force opposing the motion is how we manage to reduce the speed required for a magnet to cross the copper tube.
The objectives of this project. With this project, our objectives are firstly to prove when introducing a semi-free falling magnet object through a copper tube, it exerts a force that will prevent it from continuing at a free fall speed, reducing where necessary the constant acceleration of the Earth. On the same, as a second objective is to compare how much the falling speed of an object is related in the same scenario, but without being affected by any magnetic effect. The materials that we're going to use is liner paper, glue, neodymium magnets, copper tube of 1 inch, boxes, eggshell cardstock, 1 shoe box, 2 small boxes, wood sticks, 1 marble, UHU glue, black and gray paint, white sheets, rock paper, paving supports, wood, and Legos.
So now I'm going to explain you how we created this project. So the first thing that we did was to make the bases with the boxes. On this basis we placed some pillars as supports that I had from past projects. Into supports we put an axis, and over that axis we put the copper pipe. This was to give it a certain inclination. Then we made the roads with the cardboard that we painted black. The white lines of the road were made with sheets of paper. The containment bars along the road are made of gray painted cardboard. Inside the pipe, we put a cardboard to make it look like a tunnel. Then, we put together the tunnel and the road. We tested its inclination on several occasions. And finally, we decorated the project with rock paper, paint, and Legos. This project has a very simple dynamic. By placing the white marble and letting it roll through the road and the pipe, it maintains its normal speed. However, when a neodymium magnet travels the road, it obtains a normal speed, but when entering the copper pipe, it reduces its speed thanks to the magnetic field and to the Lenz's law. When it comes out of the pipe, it recovers its normal speed.
Complications. The complications of this magnetic slowdown project was getting the right materials, like the copper tube of 40 to 50 centimeters and the neodymium magnets. Also, while the project was being built, it was necessary to wait for the glue, the paint, and other things to dry to be able to continue. Also, at the time that we were obtaining the materials, as there are not enough places to get like small pieces of the copper tubes, they only sell it in 1 meters format, and we only need half of that. So it was difficult to get the copper tub. There was also complications of the experiments because we didn't have a lot of information about the topic. So we tried with different magnets, but at the end we stayed with the neodymium magnets that worked the best. Also, there were some complications to get some materials like paper, paint, some wood, and those kind of stuff because of the COVID-19 pandemic. But well, I think that we made a pretty good job, and I expect you to enjoy it. In conclusion, magnetism is a phenomenon associated with magnetic fields, which arise from the movement of electric charges. This movement can take many forms. It can be an electric current in a conductor or charged particles moving through space, or it can be the motion of an electron in an atomic orbital. Lenz law was determined by the scientist Heinrich Lenz in 1833 and says that the direction of the currents or the induced electromotive force is such that it always opposed to the cause that produces it, that is, the variation of the flow. And about the experiment, as we supposed, the most difficult part was finding out a good experiment. However, we made a magnetic slowdown phenomenon with neodymium magnets and a copper tube. We expect that you like it. We made this as a highway. When the magnets go across the copper tube, when they were slower than a normal object. Then, passing the magnet through the copper tube, a magnetic field is generated that opposes the magnet. It causes the slowdown